Good morning.
Good morning. How are you?
Fine.
Mhm. Okay, I don't know. Maybe we can start today. Oh, just wait a few moments. Oh, uh, I don't know. Maybe we start today. Or just wait a few moments for more students.
I think we can start.
Yeah, we can start. Okay then. And today our topic is the same one. We started looking into the memory management. But we looked only in the really, I don't know, old way to use the pointers. And this type of usage, for example, is only when you need it really to save this memory. There is some situations when you need to implement some algorithms or when you need to implement some data structures or some your own. For example, you need to implement dynamic array or use for different algorithms when you need it really to control your data structures. And that way to, like, I don't know, to use pointers to allocate and deallocate memory. Um, a lot of time when you're implementing the programs like this, you face a lot of mess around your code, and you also face a lot of memory leaks because you maybe forget sometimes to write a delete, and there is other options to use memory management and to have some pointers in modern compilers in other standards, like starting from the C11. I know, maybe I just create some page. Um, when you starting from C11 and till I'm not sure now, maybe it's till 17 standard, you're able to use different techniques to use the pointers, which is automatically deallocate the memory. You don't need to write the delete. It's not the garbage collection. It's only the technique how to deallocate this memory. And on background, it's implemented some functionality. How it's use delete when you moving out of scope of your, for example, function block or any block in programming using the C language. And that calls smart pointers. And for those smart pointers exist few types. Later we will see those types, only the three types. And I also have some right here some text about those pointer types and how to use it we later see. And now I would like to move to the memory management. Here is some internet material, and basically I would like to show or move down as fast as I can, because here I'm just would like to show why we need those smart pointers, because we're facing a lot of memory leaks when we creating the small programs, for example, and data allocation using the heap, and also to allocate using like here, as I mentioned, when you're using the pointer, you allocating the heap, and the heap is slower because you need to ask for the system how when you need it, I don't know, some bytes, for example, for your purpose, you need to wait for your heap it's allocated. And when using the stack, in the stack memory, it's much faster to get that type of memory from the stack. And those smart pointers, of course, it's more have more performance than using the heap, and in some cases it's better to use the smart pointers, of course. And but you don't need to forget about this memory allocation using the simple new and delete keyword, because you sometimes you need to use it, or you need to use the hybrid approaches for your implementation of algorithms. And here basically I would like to show few I don't know headers, only to understand why some cases better to use those smart pointers later. And here basically shows when we facing some memory leaks, and we facing a lot of the situations, like when we just starting programming and try to using our approach. For example, we already know for Java or C Sharp, when you're using the keyword everywhere, like when you need some references, you just using the keyword new and new, like we have here. Or just I make presentation mode, Alt 1. Here it's basically, here is a Java usage, and when you use a lot of stuff like this, doesn't matter how many instances creating, here it's similar to Java, like when you have the and new 2 and etc. And when you're creating like this without garbage collection, of course you need to delete all those instances later. And here it's not the similar as a Java language when you're calling the constructor. Here is a different implementation. Doesn't matter, it's looking the same one, but in Java, if you implement it in Java way, here is Java style. You're able to implement. Here it's this line, it's similar to Java code. And of course, better to use some those smart pointers. Make unique, make shared, and because sometimes you're creating the pointer which is not sharing to all instances, and better to have the smart pointers. Of course, we not introduced it yet, how those pointers looks like, but we need to use those pointers to have better performance, or to avoid the memory leaks. Here also shows that we should use null or zero or null PTR. Now in new standards, instead of null, you will find a null PTR. And as you see here, problem with both null and null pointer value is 0 special. Basically, problem with the value. Like when you have some values, if you lost some pointer shows to this value exists somewhere, you're facing some problems. And here shows that use 0 only for integers, and that confusion disappears. But of course, instead of some confusion using the null or 0, you're able to use null PTR and you solve this problem. You don't need to know that if I use an object, I use null. If I use a string, for example, or I don't know, some objects, or if I using integer, I using 0. Instead of this, better solution to use null PTR. And like when you're checking is if null PTR, better to check null PTR. Like when you have some, for example, Anna equals null PTR. Of course, here we don't need it to check like this, but you're able to check if Anna is null PTR because it's not null, as we see here. But in some cases, you're able to get like this. Student A. Oh, it's not possible to implement because we have constructor. And now if we check also A, we're not able to check here because we have not the reference here. Now if we have reference, you're not able to implement like this, because you see you always need to use the new keyword because we need to allocate the memory. And if you're creating the pointer like this, you're able to check your but of course it's not initialized at the moment. Maybe you're able to say that null here, and null, as you see, it's old way. And if you need to say that it's null here, it's null PTR. And of course, this line shows always that checks if you're writing some code, it's really not great written. You will get some tooltips. And of course, you need to use the null PTR instead of 0 or null all the way. Like, you're able to use the null, but if you writing the new programs, you need to use null PTR instead of null. Like null is equals null PTR, and it solves some problems with 0 or null, or doesn't matter when you need to choose this. And of course, when you have some delete operation, sometimes you're facing some problems when you're deleting twice. You have the foo and you try delete, and you try delete the allocated memory. And for example, if I have delete Anna and delete Anna twice, of course, CLion shows that here there is some problems. Now it's working, it's not none. And of course, not every time you will get some crashes or some anomalies, but better do not use twice to deallocate memory, because as you see here, we have the local variable Anna may point to deallocated memory. And when you try to deallocate a memory, you maybe face some problems later. And now CLion shows this problem. We just delete this and you're not facing any problems here. And here shows this disaster when using twice. And there is, of course, programs when you're using some malloc, like C library to allocate memory, and malloc, alloc, reloc, for example, as we see also. And we have the new keyword in C++. And you're not able to delete this memory when you're allocating using the malloc function, because it's different implementation, and when you're allocating using the malloc function, you're not able to use delete keyword. You're able to use only the new keyword and delete keyword, like here. When you're using the new keyword, you're able to use only delete keyword. You're not able to use, like we have the malloc allocation function and free. It's like the same as a new. Here it's new, but in C, not in C++, and free it's like delete in C. It's really a similar functionality. You have different functions to allocate and deallocate function, deallocate memory, like, or freed up the memory. Freed up memory and allocate memory. You have two options, and of course, when you're using the C++ language syntax, you use the new keyword and delete keyword. And basically, it recommends we should use malloc, reloc. Why it doesn't have the reloc doesn't matter now. Do I need to check the null after this? Okay, now we move into more deeper. Yeah, and here maybe another bad practice when you checking like this. If a null ptr, when we like if a not null ptr, we deleting a, for example, like this. Here the wrong thinking when you have when you're checking, like when you need to delete some or free up some memory, you don't need to create some branches or if statements conditions. You just need to use only delete. That's it. And here maybe it shows, oh, just remove. Yeah. And if you would like to delete, you just delete a and that's it. You don't need to use any if statements or if checkings when you moving to would like to free up this memory. And here, what are these two steps happen when I say delete p, for example? When you say this keyword delete, basically on background it will check if p, that means it's automatically checks that one line in background. You don't see this one, but it checks if P, or if P not null PTR, if this memory exists, we call the destructor. Destructor when your object is destroyed. And because in C++ world you have constructor and destructor. And this destructor used by default one. And it calls p thread your destructor, and after this it calls delete p. Basically is as you see here, primitive similar in the spirit to the free p. In background it calls delete function, but this delete function is really similar to the free function in C world. In background you calling delete function, which is deallocates the memory. Like when you're calling this line, it in background you executing this stuff, like checking is not null because you don't need to use this, checking because it automatically checks, and calls destructor and calls function which is deallocates the memory. And after this you are sure that you have freed up your memory. Now, why doesn't delete null out its operand? First, using smart pointers, one here. When we looking at the smart pointers, you don't need to write those deletes, because when you have the huge projects to use only the delete keywords or allocate the memory, you're facing a lot of memory leaks and faces some problems. And you're not able to use some delete p plus 1 or delete fx and etc., because you better to have some simple delete statement, because if you write like delete p plus 1, you don't know at the moment which address here to delete. And here it's more examples when we're facing some problems. Free leak exception. How to allocate an allocator array of things. When you have some array, I also already showed that is here. You allocating 100, for example, array elements of the thread object, and when you're deleting, you need to use those brackets. If you forget to use those brackets, you will face some problems and memory leaks, of course. Now we're moving into more details. Can I drop deleting of array, built-in char, and etc.? Oh, as you see here, we have some array, or just array of pointers, and we just deleting p. Error should be delete p. You need the brackets. Okay, short answer magic. Allocate multidimensional arrays using the new keyword. Yeah, here is really hard to say when you need to allocate the matrix, because you're able to allocate using only when you have some stack or you have the array. You're able to say that this array have n rows and n columns, for example, like square. And when you use the static, like allocating using statically or using the static way, the stack in the fixed size, you're able to allocate the matrix. When you're using the memory allocation, you're not able to allocate multidimensional as a static way. You're able to allocate only multiplication of rows and columns. And that doesn't mean that you will get the matrix image, or I don't know, it's drawing as you see, because you're allocating only the numbers, like for the single array as you see here, and you will get some n rows multiplied by n columns. And here when you allocating this memory. And here, of course, you allocating the huge chunk of memory when you need some matrix, for example. Here is some solutions, how that matrix implemented. And there is a simpler way when using the object, creating the matrix. Generic. What another way to build a matrix template? Okay, we don't need a matrix at the moment. Have whose length can be specified at runtime. Question is, built-in type array have the length of specified at runtime. There is only one way to use expanding or growing data structure. It's only the vector, the template of growing array, dynamic array or list, only for this case. And when you have some simple array, you're not able to during the runtime to expand your arrays. And for example, when you have some array, doesn't matter any, int array, yeah, it's maybe 25 size. You're able to also, we already maybe implemented array of integers. We have some array representation, but here, as you see, during the runtime, you're not able to expand or to change this array size. And for that reason, when you need dynamic array, better to use vector data structure. Like as we also see the vector and numbers, for example. And when you have the vectors during the runtime, you're able to add elements, and you don't need the real size of your vector. It growing up when you need numbers, you just push back, for example, number like this. And later I will explain when the vector have some memory or performance issues. When you're using like this, it faces a lot of memory wasting, like this, when using this vector. Instead of a simple built-in array, it recommends to use the vector template or vector data structure. Built arrays need to have the length at compile time, not able to use at runtime to use your at runtime use to change array of integers, for example. Because here you say that here is a fixed size 25 elements of integer and you're not able to store more. You're able to create different array, but it really, in some cases, array is evil. That represents like it's not great solution. And reference counting. Okay. Reference semantics. Prevent people from counting. Can I use garbage collector? Oh, here it's really interesting topic. And when you have different programming languages, some programming languages have garbage collection, which is automatically take cares for the memory. And of course, when you have C++, there is some garbage collectors already created. And in C++ 11 offers garbage collection ABI. And why in some cases it's good or bad usage of garbage collections, it's like and as you see, garbage collection used for specific needs such as inside implementation, log-free data structures, avoid other issues, default handling, resource management, and of course it says that garbage collection not the best way to implement your programs, but in some cases it's okay. And we need to look, of course, to the smart pointer techniques, and after this we see that smart pointer is used at the top article and here, and for that reason we need to look at those smart pointer techniques and compare with smart pointer techniques. Garbage collector techniques are less portable because you need to download or to have special compiler, and you need to have some for example special libraries to use this garbage collection. And also when using garbage collection you're able to get some memory leaks also and work better with existing libraries. And if you, for example, if you're not using the standard libraries, using your own libraries, garbage collection will be not so great usage, for example, for your own created data structures or some code in some cases. And if you need to be able to use the garbage collection, it exists, and if you would like, you're able to see that, for example, C++11 offers garbage collection ABI. Basically, it's for automatically deallocating the memory when you're creating objects. And here it's two types of garbage collectors. It's like conservative garbage collector and a hybrid garbage collector. Basically, it's different different implementation or how those is working, different implementation of memory deallocation. Where can get more on garbage collectors for C++? Here is some links. You're able to read it more about garbage collections. And here, as you see, what is auto PTR and why there is an auto array. Before in the first implementation of smart pointer exists auto PTR, which automatically deallocates the memory, and you're not able to deallocate the array or create PTR for arrays, and for that purpose it was solved and change it to unique PTR. And unique PTR supports both single objects, reference, and arrays. And you don't need to use the auto PTR because it's old implementation, and this keyword is deprecated already. And if it's deprecated, in some cases you will see in code, you need to change to this unique PTR. And basically we now already go to the smart pointers. We see few examples of few cases about the memory, how it's using, how it's checking, and when you have the huge projects. As I mentioned, from the C++ 11 to C17, and now it's 20, for example, it should add it as a standard library, smart pointers. Smart library means when you're using std keyword, standard library. std, and you're able to find your smart pointers. And how to use those smart pointers. I have some material and there is some different pointers. Here, as you see, it's scope pointers. Scope pointer, it's in our case, it's unique PTR. And scope pointer supports ownership of single objects and automatically deallocate the objects when the pointer goes out of scope. So sometimes they are called auto pointers compared with auto PTR. And now auto PTR is deprecated, we're using the unique PTR. Scope pointers are defined as owning a single object, so it cannot be copied. That means you creating the pointer which is not able to copy it to another place, or just it's more to as a singleton, but it's not, of course, not as a singleton, but it's really familiar to singleton object. And unique PTR, that why it's mean that unique PTR. It's like a constant PTR. And usage of smart pointers, it's really great when you don't need to write delete keyword. You're just allocating the memory, and automatically when you're out of scope, you deallocating the memory. How it looks when you need to implement. For example, we have some data structure. I don't know. We create some different data structure or class. Memory. We have the class memory, and in memory we have int size, for example, private size and or just std string type. Size, amount, okay, just we have some functions, public for example, and void, or just we create getters, alt insert to generate getter. For example, get size and get type. We have some functions. We need, of course, to make the setter for more functionality. Setter, set size, set type. And now we have some memory class. It's like an object-oriented program. It's really basic implementation. There is no functions. Maybe we're able to add custom function, void print info, and we just leave like empty function. And for that case, we have some memory. And for example, also we're able to create some computer class computer, and in this class we're using the we're using and okay, std string type, not type or name. And public, we have some function. We're not using as a composition, we're using some function which is using the memory. For example, we have some function void add memory. Doesn't matter really, we're using some memory. And when you need to pass some reference or object, you passing, for example, that type memory. And I'm not splitting the implementation and prototypes in header files at the moment, only for easier to see implementation here. And when you passing the memory, as you see here, you passing the object. And when you passing the object, we able to use later for our case. For example, memory dot get size, like std and line. And here we passing, for example, just function added memory, and here it's size, for example, gigabytes of added memory, for example 5 gigs, or doesn't matter when we passing some memory. And also we need some constructor maybe, or we use default one. When you not implemented this constructor, you will get default one constructor. We try to, I don't know, we need it or not. Maybe I use constructor because you need to see how it's work with unique PTR or those smart pointers when you have some parameters. And we able to generate constructor with initialize size. And this one means like you when you create an object, you're passing the size of memory. That's it when you are creating the object instance. Here it's suggesting to just write explicit. It really doesn't matter if not leave it there, like, without explicit, it's working the same way. Here basically it's only for that single value constructor. You're able to leave like this, it's working like as you intended. And here now we see some problems. Of course, it doesn't matter, it's generated code. And white shadows. It shadows. Oh, maybe it's when we have some implementation of this. Maybe we just remove this set size because we already have the memory constructor which one is automatically sets or initialize the size. Now shadows. I don't know why it's stated here the shadows. This maybe it's okay now because it's generated code. And when you see those yellow stuff, you will see here that it's recommended to use different stuff. The parameter memory is copied for each invocation but only used as a const reference. Consider making const reference. That means when you're passing from the outside, you're making the copy and you're passing this copy to this scope in here in computer implementation. And for that reason, you just copy and copy those instances. Instead of this, recommend to pass the reference of the const. That means you passing only the reference instead of copy of the memory from outside. Like when you calling this function, you passing only the reference instead of copy of this instance memory. Basically, it suggests for you. Add memory also can be static. Here it's really your choice, you're able to make the static, adding static keyword. And that means it's not depends on your computer instances. If you leave like this, it depends on your computer instances. Like when you're creating computer, or just we moving here, easier to write now. When you're creating computer, size. Okay, we write IBM. No match constructor. Oh, it's computer, just computer. When you're creating like this, IBM and Lenovo, for example, and if you're not using the static keyword, you're using different IBM functions. Using the same function, but using for this IBM depends or belongs to IBM add memory, and Lenovo belongs to Lenovo add memory. It's two separate functions. When you have the static keyword, basically you see a problem here because the static member access through the instance. For that case, when you have the static keyword, you're creating only the single instance of the add memory, and you don't depend on the instances of this type computer, and you're able to reach this method using computer add memory directly using this type, because you have the single instance of add memory method and you don't depend on those instances. Here's two different ways when using the methods. When you have the static, you calling this add memory only. For example, you need to call this function, for example. There is no point to have those two instances to call the same method. But if this method have different implementation, you need to use not a static methods when you need to use the instances. And here only when you have the same functionality or same method using static method call, or here when using the instances. Basically in memory it looks like I already have some draw, like when you have like this, you have the static stuff. Here it's static memory, for example, and in static memory you able to reach only the single reference. It's like object name, like if you have computer you're able to go only using the computer reference to reach this static memory. When you're creating the computer instances, for example computer C1 and computer C2, it's like some names of computer. You have some memory, and for each computer instance, maybe it's wrong here. Okay, now I create like this. Basically, when you have computer in static memory, it's in down here. It's like in bottom, you will get some static memory, and you're able to reach directly using the computer or type name. When you have computer instances, you're creating two separate memory blocks, and that means when you calling is not static variables. For example, we already have methods. I forget add memory, like add memory. You have two separate memories and you have two different scopes. Here add memory and here add memory. When you have the instances, you call different function. You're creating different instance, and this different instance have different instances of properties and functions. And if you on computer implementation have the name, if this name is not static, that means name is here and name is here, and you have two different strings of the name. If you change to the static, you will move then to the name here, and that means you're not able to change the name, because you're able to change the name, but you will have the single name for all computers. And here, when you have the static keyword, like this, if you have, for example, maybe we need to create a function which is set the name. And if we change to static now, we change it here static std string name. And basically we need to implement computer, I forget now, name, not name, I need to check, static example, C++ class, I'm not sure. No, maybe we need to implement outside string or std string computer. Why it's not reaching this? We need to create a public. Name equals, for example, my computer. Yeah, and for that reason we need a public. And when you have some public, you need to implement outside the name. And std string computer name equals my computer. When you're using the static keyword, you will have the same computer name. And you're not able, for example, use like this IBM dot name. As you see here, static member accessed through the instance. It really doesn't matter, we'll get the same name of my computer. Maybe we try to print it out. Is it possible? I'm not sure it's now printed or not. IBM dot name. Okay, here. IBM dot name, std and line. And now we try to print it out different, Lenovo. We have some problems also here. Why it's here? Oh, it's forget this. Here, when you're initializing the static, you're not able to initialize inside the class. You need to initialize static keyword or static properties only outside, like this. Computer name. And when you're running the program, as you see here, we get my computer, my computer. Doesn't matter which instance you're using, you will get the same, oh, sorry, we need a top. We get the same name because we're using the static memory. And if you, for example, changing the IBM name equals or just maybe we try to use the set name, if it's possible, to IBM. And as you see, when we setting the name, we will get the same for the both instances, because we're using the same address and same storage. Like here static memory, and here is a computer memory place where is the static memory, for example. And it not depends on the instances when you have the static keyword. Sometimes you need it because when you have some math functions like try to square root or to calculate sinus, or doesn't matter which function, better to create a static, because you don't need to create instance. For example, when you're calling math, better to call like sinus, like passing number. Better to use like this instead of creating like math m, or just, I don't know, constructor, and then using m.sin, for example. It's really useless to write two line of codes when you're able to write directly and call this function. And in that case, recommend to use not instances. When using the static, you need to use computer, and here using the reference to the name, or just create a function which is get your computer name. And when you need this type of computer name static field, you need to call like this instead of using those instances. But if you have some instance and you're changing this name in any name, for example Lenovo, you will get the same name, of course, because you're working with the same static memory. And it's really not every time you need to use those static, but it's a lot of places when you need to use the static keyword. And here basically we already looked into the static, and we able to start those pointers. Unique PTR. And how to implement this pointer? First, you need to include memory library standard. And when you have some memory, you're able to use the memory allocation or smart pointer without deallocation. You don't need to delete. It automatically cares for deletion. And now when you need to create a pointer, I'm just maybe moving here. And now I'm adding smart pointer section. To create, you need to call std standard library unique PTR, and here you're passing which type of pointer you're creating, like computer maybe, and or just memory, because we have more values and methods. Here we're creating the memory pointer, and here there is two ways to implement this memory pointer. You're able to implement using constructor new memory. Oh, I forget. Memory in size, for example. Oh, sorry. 8 gigs of size, and you just created a smart pointer, which is really helps you to solve the problem when you need to write delete. You don't need to write delete, you automatically will be deallocated. And here, of course, the one approach how to create smart pointer. Basically, when you're using the memory and this keyword, you're able to which methods we have in memory: print info, get size, set type. Print info. And as you see here, you will get the arrow. The arrow keyword means that we're using the pointer, not the stack memory, but we're using the heap. They're basically the same as we creating memory like this, new memory, 2 gigs. And when you're creating like this, you need to write every time delete memory 1, for example. You don't need to not forget to write like this. Instead of this, from the C++11s, added smart pointers. Auto deallocate memory. And that helps you. Doesn't matter if you write delete, you don't need to write delete here, because here you must to write delete when you finish work, or here you just automatically will be deallocate the memory or freed up memory. Freed up like this. And when you're freeing up the memory, you don't need to manage your memory a lot of like in the past when you need to delete and new keyword. Of course, this one it's not disappear. You some cases using that new and delete, but basically now we're able to use that way to using this smart pointers. And when you calling the computer, we already have the computer IBM Lenovo, IBM add memory, for example, and you're able to pass the reference of the memory. And when you're passing the memory, you need to pass the reference or pointer. And as you see here, for example, I'm able to add this memory using the unique PTR, same as I'm able to add memory, also IBM add memory using old way implementation. Oh, I forget those. Okay. And here, dangling pointers. Maybe we just add Lenovo. It's more useless. And here we're able to face some dangling pointers, which, as you see, shows to deallocated memory, because we already deleted. And of course, when you're using this old way, when you're managing your own manually those memory, you will face some problems like that deallocated memory, or you will face some problems sometimes. When using smart pointers, it's hard to make mistakes because it automatically deletes when out of scope, and you're not able to face like this situation when you deallocate memory and now try to add this or pass this reference deallocated memory to your function add memory, because it will work, but it will face some issues because it shows to deallocated memory, which is give bad results or not these results which you expecting. And for that reason, I recommend now to use those smart pointers, and it's really not hard to implement. It's instead of this pointer symbol using std unique ptr memory and new memory. If you don't like to use a new keyword, there is another approach how to implement the same. Unique ptr, passing memory and passing, for example, second memory, and instead of this you're able to add like this, make unique memory, and you passing constructor like 16. Here is basically the same approach of this, instead of new keyword using like this. And you're able to use the second memory as you intended using the same pointer. And now we just move this delete memory here to solve this problem. And of course, if I write a comment, I make it here. And add memory, you just passing the reference as object. Memory, you're able to change some stuff, print some stuff, do like before, like memory, I don't know, set type, dim, for example, dim type. You're able to do the same operations as you intended, but it freed up when you finished, when you out of scope. And what does it mean, the scope? Your scope is your function scope. If statement scope is any block. And for example, like this, when you're adding those begin end, that means here is a scope, and when this go out from this scope, you will automatically will free it up. We able to write some destructor to see the results, for example, for memory. Destructor is like this, alt insert destructor, std cout object and destroy. I don't know, do we see some stuff? Oh, we had a different scope. Okay, we first just leave like this and run the program. And when you now it's hard to see here, maybe we need to create a functions, for example, void a, void b. and we try to call those functions later. Just moving out those smart pointers here. And second memory. Basically here it really doesn't matter, I just delete this at the moment. I show how it's passing parameter is the same when using this. And now we have the smart pointer A function and smart pointer B function. And when you're calling this function, function has scope. As you see here, this block means that here is your scope and here is your scope. After it leaves the scope, you automatically will be freed up this memory. And as you see, of course we get the third one because we use delete keyword here. And we got two object destroyed because the first, after it goes out of scope, is freed up memory. Free up memory. After finish this block, and you don't need to make delete or any stuff here. Basically, if you remove this, you will get twice to see object destroyed at the top. And here, as you see, we got object destroyed, object destroyed. That means you call twice, first, second, and after this it automatically calls destructor and delete or freed up your memory. You don't need to write delete keyword. And unique PTR you're not able to copy or to change. It's like the constant, like how to see that is not changeable or not, you're not able to change. We create another pointer here. For example, we have second, and if you try to memory equals second memory, you're not able to do like this. Overall deleted. You're not able to make like this. You're not able to copy this function when you have the unique PTR. Void, maybe we create shared, or void C function, doesn't matter. In C function, we creating shared pointer. Shared pointer, it's really usable when you really need it, because if you're able to use it unique PTR, better to use only unique PTRs. When you need some situations, when some pointer shows different pointer, you need to use the shared pointer, shared PTR. Like std, I will use the make shared memory and 5. And the difference between the shared and unique, that you're able to point to different memory. And we have the shared PTR, for example, A, B, and C. I don't know, maybe I leave like this, B and C. And there is some problems when you have some shared PTR. And now we read what does it mean. Shared pointers are reference counted pointers where the reference count incremented by 1 when a piece of code wants to hold onto the another pointer, decrement by 1 when it's finished using the pointer. When the reference count is 0, the object pointed to the pointer automatically freed. So the shared pointers can help avoid the problems accessing freed memory and ensure the pointers remains valid period to which you use it. Basically, it has some, if you show two different pointers, like to A, B, it counts as 2, and when you're not using, you -1, and when you're 0, it's freed up. Like some math in background. It counts the references. And now I show the example when we face some problem. Share pointers. And those share pointers, I will find some problem. Here it's a lot of, here's from SharePoint. When you have the object A, object B, and object C, as I created also here is A, B, C. And for example, A shows to B, B shows to C, and C shows to A. And for that reason, when shared pointers show to the another pointers, it counts, for example, references. Because A have two references, B have one reference, C have one reference. And the problem is when you show like this, you will get some cycle or loop circular dependency. And when you have the loop, your smart pointer not freed up. You're just looping your function. Here is some solutions. In general, deciding where to put weak pointers. Instead of share pointer, you're able to make the weak pointer, which is finish your infinity or cycle. Some objects should be weak pointer instead of share pointer when you face that situation. And here it's in general, weak pointers might be complex. You need some kind of symmetry among the objects in the cycle in order to choose place to break it. You need to break this cycle. In this kind, you know that a object is referred to by the rest of program, so we know the place to break the cycle is whatever points to A. For example, we able to break this loop because we're looping around some weak pointer, for example, object C, and that breaks the infinity or just shared object loop, and the reference count will be 0, and after 0 it's freed up. And here it shows link C to A into weak pointer. C to A. And basically, when you have like this, we need to say here shared ptr A is equal, if I get A to B, shared B. When you have the shared PTR as a C, you're able to show to different pointer, because when you have unique pointers, you're not able to make like this. And A to B, A to B, B to C, share to C, and C to A. Of course, those type situations, I don't know, it's really a lot of time happens, but you're able to face this problem. When you have some objects and you making this circle or cycle problem when using share PTR, because you're able to use like this. If you have the unique PTR, you're not facing this problem anytime. And here it's a solution to change the there is of course maybe different solutions. You're able to pick C shows to A, and you need change the link from the C to A into weak pointer. That means you need to say A to the weak, for example. Instead of shared PTR, using weak PTR. Weak PTR. Make weak. Make. Is it possible to make weak or not? Make pair, make shared, make unique. Or make shared is the same, sorry. It uses only on the left side implementation in only the weak PTR. That means, of course, it's the shear PTR, but is weak when you need to stop this loop. Or it's not here, A or C, I don't know. Weak PTR. If we make here shared PTR. Okay, we make the weak PTR then. In some cases, you need to think which is weak PTR and which is shared PTR. But better, instead of weak pointers, if you really don't need it, use better unique PTR. Because it's at our case when we creating the programs, like the simple programs like this, when you have some objects, I don't know, it's anytime you need to use the like this that share pointer A equals B, B equals C, and C equals A, and for that reason it's also added solution using this weak pointing, and only not face the problem when you looping through the pointers. Basically using share PTRs if you would like to store a copy of another pointer or point to another pointer when you need it, and unique PTR when you, I think in object-oriented programming you will face more unique PTRs. And here is automatically deallocating the memory or freeing up the memory when you finish work with this memory. And weak and share is the same, but weak is to say to break your loop only. And basically there is some another topic when you're using smart pointers modern C++ in official Microsoft documentation. Here is some examples. Here's a row pointer when you have the similar, like simple object, and you using the unique PTR. Basically, I already showed this unique PTR, and we have another way: unique PTR, P large, process P large. We already see like this when you're passing some reference to the method. If you need to delete or deallocate memory earlier, because when you create the memory, you need to call sometimes to delete or free up this memory, and for that case you're able to use reset function. Free the memory before we exit function block. If you need, for example, to work with memory, and here, for example, you making more stuff, you're able to call memory.reset. Just it's freed up memory earlier before you end your function, and you're able to print it out, for example, something working, like be able to make more work and release or freed up earlier using memory reset. Here, create object pass it smart pass raw pointer to legacy API. plart.get, and maybe that's it for our today lecture, because here you'll find also unique PTR, shared PTR, and weak PTR. Basically, all knowledge is only you need to know the unique PTR keyword, shared PTR, and weak PTR if you're facing that loop. But I think that you never face this loop. Of course, you never know when you're facing, you maybe see that problem. How to detect this? Better, I think, that draw some image like this, because it's when you're looking here, you're not able to say to detect it's cyclic or not cyclic sharing between those references. And if you're implementing some data structures, I think that you also need to draw that diagrams first before you implementing those shared and not shared references. Basically, you need to try yourself to implement some, for example, data structure using only the smart pointers instead of simple pointers, raw pointers.